Welcome to this M1 video on motion in 2 dimensions. So this time we are going to continue looking at problems involving F equals ma. However, this time both F and A are going to be vectors. Okay, and that's what's going to describe our motion in 2 dimensions. Now, there's not really much else to explain for this one, I think, so let's jump straight into an example. So here we are given a resultant force of 6I plus 10J newtons acts upon a particle of mass 2 kilograms. Now I should say I is obviously horizontal, positive I would be east if we were taking directions, compass directions, and positive J would be north. Now what we're going to find in the first instance is the acceleration of the particle in the form Pi plus Qj meters per second. So part A, we're going to start off with our F equals ma. And F is going to be this force, 6I plus 10J newtons. The mass is going to be 2, and A is obviously what I want to find. So dividing by 2, I get that the acceleration is 3I plus 5J meters per second squared. So nice and straightforward, I think. Now, part B, the magnitude and the bearing of the acceleration of the particle. So let's think of our directions. So if I look here, I've got 3I plus 5J. That is the vector of my acceleration, which is this one. So what I want is for the magnitude of A is going to be 3 squared plus 5 squared and then square rooted, which is the square root of 34 or 5.8 meters per second squared. And this is to 1 decimal place there. Okay, so I found the magnitude. I now need to find the bearing. So first let's find this angle theta. So tan theta is opposite over adjacent, so 5/3. And that will mean that theta is 59.0 degrees to 3 significant figures. But that is obviously not the bearing, okay, because the bearing is going to be a measurement from north. So it will be this angle alpha. And alpha is 90 minus theta. So that gives me 31.0 degrees to 3 significant figures. Or as a bearing, of 0.31 degrees. And that there is both my magnitude and my bearing. Remember, bearings are angles measured from north and they're given in 3 digits or 3 figures. So that's my first one. Nice, straightforward, I think you'll find. It's just dealing with now our forces and stuff in vectors in terms of I and j rather than just in terms of a value. Okay, in this second example we have three forces, F1, 2 and 3. They are shown here, F1, 2 and 3. Given that the particle is in equilibrium, determine the value of P and Q. So for force F1, F2, F3, they're all in equilibrium, so we know that when we add them together they must equal 0. So that would mean that, 7i minus 3j plus minus I plus j plus pi plus qj must equal 0. So 7 minus 1 plus p equals 0, and minus 3 plus 1 plus q equals 0. So 7 minus 1 is 6. Taken to the other side, p is negative 6. Minus 3 plus 1 is minus 2. Taken to the other side, so q is 2. So now we have the value of F3. Now for part B, it says force F2 is removed. Given that in the first 15 seconds of its motion, the particle travels 18 meters, find the exact mass of the particle in kilograms. So when F2 is removed, our force now is F1 plus F3. So it's going to be 7i minus 3j plus minus 6i plus 2j. Or that is just I minus j. Okay, so we've got our force. And for us to be able to use F equals ma to find the mass of the particle, we also need to work out the acceleration. Now, it's going to be a constant acceleration. So the first 15 seconds of its motion means that it's got to be starting at from rest. So from rest, t is 15, s is 18, and a we want to find. So s equals ut plus a half at squared. 18 equals 0 plus a half a times 15 squared. So this is 18 and this is 225 over 2 times a. So 18 divided by that means that a is 4 over 25. So now we've got our a, just put a line there, we can go ahead and use F equals ma. So F is I minus j, m times 4 over 25. Now, it doesn't really help me with this in terms of I and j, so let's get rid of the I and j and then let's find the magnitude of it. So it's 1 squared plus minus 1 squared and square rooted, so that's root 2. So this f is square root of 2. So root 2 divided by that answer gives me that m, it's the exact one, so it's 25 root 2 over 4. And that's obviously in kilograms. Okay, so that was just a slightly harder problem, but what you've got to be able to do now is basically switch between the vectors and the magnitude of that vector. Okay, because sometimes you'll need to keep it in vectors and sometimes you'll need just like a single value, so the magnitude. Okay, and that's really all there is to it. So if you are yet to subscribe, please hit that subscribe button. If you found this video useful so far, hit that like button. And if you're willing and able to help me out financially, then hit that join button. Otherwise, let's look at a couple of questions. So I've got 3 questions here. They're all past paper questions. You know, obviously cut down, take out the parts that you're not able to do yet, but past paper questions nonetheless. So 3 of them. Pause the video now. Okay, welcome back. Hopefully you've done those 3 questions. Now let's look at the answers. So we're given 2 forces acting on P. The resultant of these forces R acts in a direction parallel to this one. Okay, so if it acts, the resultant of these 2 forces, so 2I plus 3J plus PI plus QJ acts parallel to minus I plus 4J. So it must be K, some constant, multiplied by I minus I plus 4J. So that's what we've got. So looking at my I's, I've got 2 plus P plus minus K. So 2 plus P equals minus K. And then I've got 3 plus Q equals 4K. So 3 plus Q equals 4K. So we need to eliminate the K's, don't we? So K is minus P minus 2. And substitute in here, we get 3 plus Q equals 4 times minus P minus 2. So 3 plus Q is minus 4P minus 8. So that's 4P plus Q plus 11 equals 0. And that is what we had to show. Obviously, this question in the exam then had some further steps attached to it. Okay, but that's the first question done. Okay, question 2. We got a particle of mass 4 kilograms, starts from rest and is acted upon by a force R of 6I plus BJ newtons. R acts at a bearing of 45 degrees. So for part A, this is R and it is acting at 45 degrees. And it's 6I plus BJ. So if this is 45 degrees, then this angle here in red is also 45 degrees. Now, for it to be 45 degrees, the X and the Y have to be the same because tan 45 is 1. So, you know, if I write it out in full, you know, tan 45 is equal to B over 6. B equals 6. Okay, because tan 45 is 1. But this one is like an obvious one. So, you can pretty much state that B is 6. Okay, part B, calculate the magnitude of R. So the magnitude of R is going to be 6 squared plus 6 squared, and then square rooted. So that's the square root of 72, or 6 root 2, which is 8.5. Okay, R is a force, so that is newtons, to 1 decimal place there. Okay, so C. Work out the magnitude of the acceleration of the particle. Since we know the force and we know the mass, we can use F equals ma. So this is 6 root 2, just putting in the full value there. This is 4, and then that's A. So A is 6 root 2 divided by 4, which is 3 root 2 over 2, or 2.1 meters per second squared to 1 decimal place there. Now, D. Find the total distance travelled during the first 5 seconds of motion. So T equals 5, A equals 3 root 2 over 2. U will be equal to 0, and S will be the distance that we're looking for. So S equals UT plus a half AT squared. So since U is 0, UT will be 0 plus a half times 3 root 2 over 2 times basically 25, 5 squared. And that is 75 root 2 over 4, which is 26.5 meters, and to 3 significant figures, or to 1 decimal place. And that is question 2 done. Now let's look at number 3. So what we've got here is 2 forces, the resultant of which is R. And given that R acts in a direction parallel to 1 minus 2, show that. So a bit like before, because R is 2, 5 plus PQ, and R is parallel to that, so K times 1 and minus 2. So that means 2 plus P and 5 plus Q is equal to K and minus 2K. Okay. So, looking at the top, that means K equals to P plus 2. And minus 2K equals to 5 plus Q. So substitute that one, top one, into that bottom one, we get minus 2 times P plus 2. So it's minus 2P minus 4. So 2P plus Q plus 9 equals 0. And that was what we were requiring there. Now let's have a look at B. Given also that P equals 1 and moves with an acceleration of magnitude 15 root 5, find m. I think this question I might have missed a little bit out. P is equal to 1 and particle P moves with acceleration of magnitude 15 root 5. Okay, so if P is equal to 1, then we can work out what K is. So K is P plus 2, which is 1 plus 2 or 3. So K is equal to 3. That means that R, which is K times 1 and minus 2, will be 3 and minus 6. So now we can find the magnitude of R. So that's 3 squared plus minus 6 squared and square rooted, which is the square root of 45 or 3 root 5. So that is our force. So now we've got F equals MA. The force is 3 root 5. M is what we're trying to find, and A is 15 root 5. Therefore, M is 1/5, or 0.2 kilograms. Okay, and there is the third and final question. Don't forget, there's plenty of questions in your textbooks on these. You can also get more questions online and from programs like ChatGPT. I often say that wrong, but anyway, it is very good for putting in questions. Like if you get a question that you're unsure about and you've seen how to do it and you want to test yourself on similar ones, you put it into ChatGPT and ask it to create more questions similar. Okay, very, very useful. That's kind of how to use AI to help you revise in maths. Anyway, hopefully you found this video useful. I'm not going to say everyone enjoys the maths, but certainly hopefully finding these videos useful. Otherwise, stick around. The next video will show up at the end of this video.